This term in Enhanced Maths, we are looking at the topic of measurement. We are mainly focusing on volume, but this week in lesson 1, we're looking at area, net, and surface area, something which you may have some idea about already. So if you haven't already done this, you may have done it already, make sure that you download a copy of the notes, which is here in the file section to go along with this video. All right, so what we're looking at in the notes is a review of area in the first part. So just a reminder, an area is the amount of surface or flat space within the boundaries of a certain shape. And there are some common formulas there. You can have a look at them. And you are probably familiar with some of them, if not all of them. The area of a circle is pi r squared. You will need a scientific calculator, so please make sure you have one. Pi is on your calculator, but you can always use 3.142 if you can't find pi on there. So we're going to work through these questions. Okay, so first of all, the first example. Convert 500 millimeters squared to centimeters squared. So first of all, the units, millimeters squared, centimeters squared, because it's squared, that tells me this is an area, because area is units squared. So we can use this conversion up here to convert between units. So millimeters squared to centimeters squared, millimeters squared to centimeters squared, we divide by 10 to the power of 2. And if you think about it, if you think about millimeters, not the length millimeters, not the area, millimeters to centimeters, you're dividing by 10. So if you're going from area, millimeters squared to centimeters squared, you're dividing by 10 squared. So that's one way of remembering. So you can use this conversion. So 500 millimeters squared to centimeters squared. We're going this way, millimeters to centimeters, so we divide by 10 squared to the power of 2. In other words, we'll divide by 100, and we get 5, and don't forget your units, centimeters squared. So 500 divided by 10 to the power of 2 equals 5 centimeters squared. Do not forget units. When you do the worksheet, there'll be some conversions. You can just follow these arrows and work that out. Let's move to the next question. Also, one thing I must say as well, please feel free to pause the video and have a go at all the examples before I do them, and then just check your answers if you like. So question number 2. Pause the video if you haven't had a go at this already, and give it a go. So this is the area, back to you now. This is the area we're trying to find the area of the shape, which is a circle. So area of a circle is pi r squared. R stands for the radius, but in this case, we are given the diameter. So the diameter is a line that goes through the center of the circle and goes from one end to the other end of the circle. The radius is half of that. So the radius is 1.5, and all we do is we sub that in. So area equals pi times 1.5 squared. There's times there. You put that in your calculator, and you should get 7.07. Now you'll notice there are no units here, so I'm just going to write units squared. All right, next one. The next one, part B, I've actually done this one already. It's a trapezium, so you need to recognize the shape. You can go back to the previous page and have a look what shape it is, and also have a look at the formula for a trapezium, which is a half a plus b times h. So a is the top side, b is the bottom edge, and h is the height. You sub that all in correctly. So there's a multiplication sign between there. Okay, multiplication sign there, and you type that all into calculator, and you get 0.16 centimeters squared, and don't forget your units. Okay, C. Again, stop the video if you haven't yet done this one. Give it a go, and then come back. All right, so C is an example of a composite shape, which means it's made up of two shapes, two or more shapes put together. In this case, we've got two shapes. So we've got a triangle and we've got a rectangle. So the area for this composite shape is the area of the triangle plus the area of the rectangle. One thing I must say is really important is measurement, is make sure you put all your working out, all the steps, because you can make a silly mistake or might type something wrong in your calculator. If you don't show your working, you can't get the mark. So really important to show your thinking in all topics, but in particular in measurement. So the triangle, area of a triangle is a half times the base times the height. That's the formula for a triangle for the area. And a rectangle is length times width. So a half times the base. The base is 21 times the height. Now the height we do have, but we can't see it very clearly. The height is, so let me just, is that distance there? Yeah, from there to there. And how do we get that? It is 32, which you can see here, that's 32 minus 16. That's 32 minus 16, which is 16. So the height, h, is 16. So you'll always be given the information, you sometimes just need to look for it. And sometimes do a subtraction. So that's the area of the triangle, half times base times height. And the area of the rectangle is 21 by 16. And we can put that in our calculator. So the first bracket gives us 168. The second bracket gives us 504. And we add that together, we get, no, sorry, it doesn't give us 504. It gives us, my mistake, it gives us 336, I should say. That's a bit better. It gives us 336, and that gives us 504. I was a bit ahead of myself there. So 504, don't forget your units. So centimeters squared. All right, let's move on. Okay, surface area. All right. Surface area is, if you think about if you have a 3D shape, so a solid, so for example, a cube or a cylinder or a pyramid, you have any 3D shape, if you were to cover that 3D shape with, say, wrapping paper, how much wrapping paper would you need? What would be the area needed to cover that shape? Okay, to cover that 3D shape. So it's basically when you're trying to find the surface area of something, you are adding the area of all the faces. Now, it's important to count how many faces you have because, for example, we look at this cuboid here. We can see this side here, but there's also one behind it. And you can see that a bit clearly because this is sort of a bit see-through, but sometimes it's not very clear. So make sure you just count all the faces. In this case, we've got 1, 2, 3, 4, 5, 6 faces. Okay. One way of making sure you don't miss out one of these sides is to draw the net of a shape. So the net of a shape is when you take a 3D shape and what it would look like if you opened it up. So in your, just to show you before we do the next example, in the lesson here, there is a file that says extra examples of nets of 3D shapes. And that is this file here. And all this file does is it just goes through different nets of different shapes. So for example, a cube, if you were to open that up, what it would look like. A cuboid, what would it look like? As well as it goes through how many faces there are, and how many edges and how many vertices as well. A cone, a cylinder, etc. Okay, this might actually help you a little bit with the worksheet as well, because it goes through different nets of a variety of different shapes. Okay, so let's go back to this question here. Okay, so this example here says find the surface area of the cuboid below. So this cube here, cuboid. Okay, so we have a look at this cuboid, what can we see? Now, when we're trying to find surface area, you can write SA or you can write TSA. So, all right, surface area. TSA stands for total surface area. I'm just going to write surface area. SA equals. All right, so what can we see? We can see we've got this side here. So this is 3 by 2. That is a rectangle we have on this side. We also have the same rectangle on the other side. So we have 2 rectangles here. So 3 by 2 and another 3 by 2 on the other side. So we have 2 3 by 2s. 2 times 3 by 2. That's a times there, by the way. Plus, what else do we have? We have, I can see this side here. This is another rectangle. 4 by 3. And I would also have the same thing replicated on the other side that I can't see. So 4 by 3 and 2 of them. 2 times 4 by 3. And there's one I haven't counted yet, and that's the top and the bottom. So this is 4 by 2, and I have 2 of them. I have that on the top, and I have the same thing replicated on the bottom. So if I would turn this upside down. So 2 times 4 by 2. And I can put that all in the calculator, and I end up getting 52. And I do have a unit, which is centimeters squared. Okay, because it's area, total surface area, or surface area is an area, so it has to be squared, the units. There is this applet here that you can have a look at. So I'm going to just quickly open it now. And what you can do is you can actually replicate that using this. So I'm going to take this, remove this. I'm going to draw this cuboid. So it was 4 by 2 by 3. And so that's the shape. It's obviously rotated differently, but it is that shape, just rotated in a different angle. I can show the net now, and you can see it's color coordinated, so you can see the sides and what it would look like if it was open. And then you can even check your answer, and it goes through the calculations. And this is probably even better in that it actually shows an extra line of working, which is a really good way of setting out your work. Okay, so that is for that one there. Now, we'll go back to the worksheet again. So that's that total surface area there. The rest of this this handout goes through the surface area of a cylinder. I'm not going to go through that now because you're going to investigate that in the worksheet. Just notice that's the radius there, and that is the height of the cylinder there. You can have a read of this later. If you're interested in some more applets on surface area, at the end of the notes handout, there are some applets and there's some videos here if you want to have a look at them. So now once you've filled in those examples, so we've done this first video, this second video down here is optional. So if you want some more examples on surface area using a net, and you can see this is a different example, you're welcome to watch it, but that's only if you need to, okay? So that's there for you. Then what I'd ask you to do is, for your teacher, please make sure you have a go at the worksheet, which is here. This is the same worksheet as this PDF file here. So this Word file and this PDF file is exactly the same. It's just if you can't read the Word file for whatever reason. And so make sure you save your work in your D drive after you're done. Check your solutions, which are also at the end of the worksheet as well. And have a great lesson.